Hello students, a very good evening to all. I hope all of you have done your INICET 2023 exam well. Now for the main session, we are having the recall session. In this session, if you see, two subjects seem to be very tough, PSM and pharmacology, based on the info from the students. Now we will see the questions from PSM. Don't worry if you have got it wrong also, because many questions, they were beyond your scope or beyond your reach. They were at the PG level. So usually if you see in the exam, 20 questions from PSM. In this 20, 15 will be easy or medium and 5 will be tough. So 5 can be out of the reach or your present level or post-graduate level questions. But if you see in the present exam, as for the feedback from the students, as far as the feedback was concerned, 10 to 12 questions were tough. So the first question. So, one among the following statements is incorrectly matched with regards to epidemiological studies. See, whenever we do an epidemiological study like a case control study or a cohort study or a randomized control trial or a systematic review meta-analysis, how we should do? They have some guidelines. So they have some guidelines on how we should do. It is called as the checklist. So they have a checklist for various studies. So while doing the study, you have to see the checklist and see whether the study is done according to it or not. So the checklist for systematic review and meta-analysis, that is systematic review and meta-analysis, it is nothing but PRISMA, it is right. So PRISMA, you can remember as SMA, systematic review and meta-analysis. You can remember SMA, systematic review and meta-analysis. PRISMA, it is for checklist for systematic review and meta-analysis. Next, straw. This straw, it is used for observational studies. Observational study means like case control study, cohort studies, or observational studies. For this, the checklist is the straw. Next, for RCT or randomized trials, we draw a diagram and we use something called as consort. We use something called as consort. But CARE, this CARE is not used for diagnostic studies. If you see CARE, it is nothing but it is the guideline or checklist for case report. So what is a case report? Now a new case. For example, the first case of COVID-19 that came into the world or that was introduced in China, or maybe that came or the new onset disease first in China, it will be described by the help of a case report. It will be explained by the help of a case report. How to write the case report? We have a guideline that is called CARE guidelines. It is not for diagnostic studies. So this is wrongly matched because CARE stands for case reports. So this is for randomized trials, we have a consort. For systematic review and meta-analysis, we have PRISMA. Then for case reports, it is CARE. Then for diagnostic studies, it is STAR. For diagnostic studies, there is something called the STAR. For observational studies, it is called as STROBE. For observational, OB stands for observational. STROBE, case report, CARE, CARE. Systematic review meta-analysis, MA, yes, so it is PRISMA. Then randomized trials, it is consort. For study protocols, before doing a study, you do something like plan. Before building a house, you put a plan. Like how you are going to do a study, you do something called study protocol. How to write a study protocol? The guideline is called SPRIT. It is called as SPRIT. Then MOOS, it is nothing but meta-analysis of observational studies in epidemiology. So MOOS stands for meta-analysis of observational studies in epidemiology. These are various guidelines. These are from postgraduate level question. Next, this was also a very difficult question. So it is, I think if you have done it correctly, you are a genius. You are really a genius. So calculate the degree of agreement for the following study between Mantoux test and ICRA. That is the interferon gamma, say like the blood test we used to do for TB. But now blood tests are banned for TB. Maybe research purpose can be used, but for routine purposes, blood tests are banned for TB. So we are doing like a Mantos and a interferon gamma assay, and they are comparing whether those persons positive for interferon or positive for Mantox, and those who are negative for Mantox or negative for ICRA. So two tests they are taking, test number 1 and test number 2, and they are seeing how the results of the two tests match. How the results of the two tests match. So one teacher will teach you a lesson, another teacher will teach you on the same lesson. How much it is matching. So this is called as the level of agreement. This is called as level of agreement. So this is called as what statistics? It is known as kappa statistic. It is known as the kappa statistic. It is known as the kappa statistics. So what is the level of agreement between two types of tests or two teachers? So we can take two radiologists. One radiologist is looking for TB in all the X-rays. Another radiologist is looking for TB in all the X-rays. Then we are correlating the results of the two radiologists, how much they are agreeing. So how much they are agreeing, how much they are disagreeing, how much they are agreeing, how much they are disagreeing. This stands for when both of them they tell the disease is TB. This stands for when both of them that tell the disease is not TB. Here there is disagreement. These two stand for agreement and they stand for disagreement. Based on this, we are going to find the value. So just this is the formula. Kappa statistics is nothing but probability. P stands for probability. That is nothing but probability of observed agreement divided by probability of expected agreement. 1 minus probability of expected agreement. So no need to panic. We need not panic. So we have A, B, C, P. So totally we have 100. We have 100. So we have 140 and we have 60. So the gross total is 200. So what is the formula for kappa statistic? So probability of observed minus probability of expected divided by 1 minus probability of expected. You can see the probability of observed. See here 80 times they are agreeing. Here 40 times they are agreeing. That gives the probability of observed. So there we can get the probability of observed. So probability of observed is nothing but out of the total 200 times, how many times they are agreeing. So how many times they are agreeing. So the total 200 times, 80 plus 40. So 120 times they are agreeing. So 120, right? 200 can 60 percentage of 0.6. That is the probability of observed. Next, for calculating the probability of expected, we need two things. So first we will take AQRA positive and Mantox positive divided by total. So row total by column total by total total. So first row total, first column total. So what is a row? This is a row. First row, second row. First column, second column. So row total into column total by total total. Similarly, what we do in a chi-square test. Next, for negative row total into column total by total total. 140 by 200 plus get 70 plus 30. Get it as 100. So probability of expected is 100 Observed, we get it as 70 plus 30 by 200, 100 by 200, so it is 0.5. The probability of expected is 0.5 and probability of observed is 46. When substituting them, 0.6 and 0.5, 1 minus 0.5, we get it as 0.2. This is the kappa statistic. So probability of observed minus probability of expected, 1 minus probability of expected. So we get it as 0.1 by 0.5, that is equal to 0.2. The answer is then, depending on the answer, see what is the level of agreement. It is a slight agreement. Kappa 0, no agreement. Less than 0 is no agreement. 0.8 to 1, almost perfect agreement. Our answer was 0.2, so it is a slight agreement. Next, vaccination is not contraindicated in one or more of the following immunodeficiency conditions. So it was a difficult question. I also searched through almost many articles. Dicot syndrome, Viscott-Alpert syndrome, ataxia-telangiectasia, complement deficiency. If you see generally from PSM point of view, vaccination. So here they are generally meaning live vaccines. So live vaccines are contraindicated in. So usually the live attenuated vaccines are contraindicated in which of the following conditions. So in immunosuppressed states, we will not give live attenuated vaccines where the immune system it cannot take it and it cannot process the immunity. So when I search through most of the articles, so the only thing where we can give vaccine is complement deficiency. See, if you see Viscott-Alpert syndrome, it was an immunological deficiency where there was mainly 3 types of disorders due to the WAS gene. There was reduced ability to form blood clots. There was accompanied by thrombocytopenia. There they told do not give vaccine, do not give live attenuated vaccine. Then for Dicot syndrome, it was a T lymphocyte development was affected. There also they mentioned do not give live attenuated vaccines. Ataxia-telangiectasia, it was also immunodeficiency condition where the patients are more prone for cancer. They also told do not give live attenuated vaccines. But in complement deficiency, they told live vaccines can be given. So this was the article where I took this data. So generally we know live attenuated vaccines are contraindicated or not indicating immunodeficiency conditions or immunosuppressed conditions. So this was the article from where I took the data. Next, Kaplan-Meier survival scale uses the following band. So this was also out of proportion question for you. What is the Kaplan-Meier survival scale? So if you see Kaplan-Meier survival scale, it is a non-parametric statistic. So we can give a drug A and a drug B for cancer. So there are people, so their chance of surviving, the probability of survival, it decreases year by year. So we are following up the patients with the drug A. So their chance of survival decreases and it comes to 0% around 10 years. Now they are introducing a new drug B. But it is starting in the same place, but where the chance of survival is increased. The patient they can even live up to 15 years. So this survival analysis, this is a non-parametric statistic. Non-parametric means what? It does not follow a normal distribution. If it follows a normal distribution, it is a parametric. If it does not follow a normal distribution, it is a non-parametric statistic. This Kaplan-Meier function that is used to denote the survival. Mainly for survival data, we use this Kaplan-Meier curve based on the lifetime data. It is mainly used in what type of study? It is mainly used in cancer studies. It is mainly used in cancer studies. Now coming back to the question, it uses the following bands. Now we saw. So Now, you see what they are saying is they are telling the band, they are using something called a band to denote maybe at 3 years after giving the drug, what is his chance of survival? It can be 30%. The confidence interval will be like some 25 to 35. Now they are using the band to define it. What is the band? Is this called as the Hall-Kellner simultaneous confidence band? Just know only the single name, the Hall-Kellner simultaneous confidence bands. Next, one of the following statements is wrong about the mean, median, mode. They are nothing but they are the measures of central tendency. The mean, median, and mode, these three are one of the measures of central tendency. So arithmetic mean is affected by extreme values. This statement is true because this mean, it can be affected by extreme values. See, normally now 3 children are there. Their weight are 3, 3, 3. So when we divide by 3, mean will be 3. Now one child is there. Its weight is 10 kg. So 3 plus 3 is 6, 10 by 3, 16 by 3, it is around 5 point something. So the mean is affected by extreme values. It is true. Then mode is used for qualitative data. Yes, mode. So usually we use mean for quantitative data. Mean we use for quantitative data. So mode or even median we use for qualitative data. So this statement it is also true. Next, median is not affected by extreme values. It is also true because how will we find median? Suppose there are 3 children born in a hospital and their birth weights are like this. What is the median? Median is nothing but the centermost observation. So since it is the centermost observation, it will not be affected by the extreme values. So this statement is also true. Next statement. Mode is the most affected by extreme values. So this is false because mode is the most repeated observation. So mode is nothing but which is the most repeated observation. For example, if there are 5 babies born in a hospital and their weights are 3, 4, 5, 5, 6, here 5 is repeated 2 times. That is the most repeated value. It is not affected by the extreme values. So mode is the least affected. It is not the most affected. Mode is the least affected by the extreme values. Next, disease caused by the following vector. So what is this vector? It is nothing but it is a mite. What is this? It is nothing but it is a mite. So the mite goes through various stages like larva and adult. So if you see the mite, the stages, what is the disease caused by this mite? It is nothing but it is a trombiculate mite. This is a trombiculate mite. It causes a disease called as the scruff typhus. How can you identify scruff typhus? You have a typically a scar, mainly in the areas like in the axilla or around the flexural areas. You can see the scar, like a black color, scar. After a pun, you have a wound, then wound kanju ponamari, the dried wound, you have some black color that is called the scar. You can see it in scruff typhus. So this scruff typhus, it is transmitted by what? It is transmitted by this trombiculate mite. It's transmitted by this trombiculate mite. You can see 1, 2, 3, 4 pairs of legs and this trombiculate mite. So triasional forest disease, it's transmitted by tick. Scabies, human itch mite. Anaplasma disease, it is also transmitted by a tick. So scruff typhus, it is also known as a bush typhus. It is caused by a bacteria. That bacteria is called as Orienta sussugamusi. It mainly spreads to people through the bite of the infected mites. These infected mites are called chigas. They will get the larval stage. They are called as chigar mite or trombiculate mite. So this larval trombiculate mite, they are also called as the chigas. Next, which among the following will not give any idea about the normalcy in a data set? So normalcy, this was also beyond your scope. So it is also a postgraduate level question. So whenever I draw a data, suppose what are the marks scored by all the students in the INICET exam? If I draw a curve, then most of the students will be around this mark, around the middle average mark. Some students may have scored very less, some students may have scored very high. This is called as a normal distribution. Anything which forms this curve, a bell-shaped curve, it is called as a normal distribution. So you are measuring something, a mark or height or weight in a class. You want to know whether it is normally distributed or not. Then you have many tests in computer in statistics. So one of the tests to determine the normalcy is we have tests like Shapiro-Wilk test, QQ plot, histogram. You all know histogram, that is nothing but it is like a bar chart without any gap. A bar chart without any gap. Histogram, frequency polygon, frequency curve. They can all tell about whether the data is normally distributed or not. Then other thing is box and whisker plot. You know, it can also tell. So if it is like centrally it is there, then Q1, Q2, Q3 in tripartite range, it is a normally distributed. Then there is another thing called Kolmogorov-Smirnov test. So these all can tell whether the data is normally distributed or not. The one thing which we cannot tell, which cannot tell whether the data is normally distributed or not, is Mantel-Hansel test. So based on the recall given by the student, we told something related to Mantel-Hansel. This Mantel-Hansel test, it is not used for testing whether the data is normally distributed. It is not used for this, but rather where it is used. It is used mainly in the observational studies. Observational studies means like the case control study or a cohort study, where it is used. So what it will do? It will mainly be used for looking for the analysis of the categorical data in observational studies. That is the use of the Mantel-Hansel test. So what are the tests used to test the normal distribution? Shapiro-Wilk test, QQ plot, histogram, frequency polygon, frequency curve, box and whisker plot, Kolmogorov-Smirnov test. So there is a dog bite for a patient who has had splenectomy. So what they are telling, splenectomy means he is an immunocompromised patient. We can keep him like immunocompromised patient. There was a dog bite, but they are just telling both the dog and the man were immunized. What is the antibiotic that should be given for prophylaxis? See, you see for the dog bite. So most of the students will think it is mostly anaerobic infection, tetanus. So we can go for metronidazole like this. You may think no. So mainly we have to think what is this? It is a broad spectrum antibiotic we have to give. That is the word given in the guidelines. In the guideline, what they have given, they have give a broad spectrum antibiotic if needed. Then avoid suturing. If you want, if there is no way, lot of bleeding, if you want to suture, give immunoglobulin around the wound. Then you may proceed, but first put maybe loose suture, but avoid suturing as much as possible. Wash the wound for around 15 minutes. Always give broad spectrum antibiotic. So one example based on the recall by the students was amoxicillin. So amoxicillin is a broad spectrum antibiotics. It can cover all anaerobic, mostly it can cover all microorganisms. So mostly immunocompromised state, we may come in category 3. Any patient who is immunocompromised, we may have to consider him under category 3. Still, there was uncontrollable crying of a child more than 24 hours. So when the crying is more than 24 hours, we can consider this as an inconsolable cry. Because normally you see babies after putting the vaccine, what they will do, they will cry. It is normal. So don't just go with cry. That is inconsolable cry or uncontrollable crying with persistent fever. It is mainly seen with the pertussis component. So it can occur as a side effect of the pertussis component of the pentavalent vaccine or the DPT vaccine. So what they tell, so avoid this pertussis component when the baby comes for the next vaccination. So now the baby is coming and putting the vaccine in the 6th week or maybe in the 10th week or in the 14th week or can be in the 9th month or putting up any time. So when the baby comes next, avoid this pertussis component. So better you can go for DT. Better you can go for DT. So better we can go for usually give the first booster. So DPT, first booster of DPT, then we are giving the second booster. So while putting the first booster, if there is an inconsolable fail, then during the next time, instead of DPT, you can put only DT. Because it is the pertussis component which is causing this. It is causing mainly severe neurological complications or sequelae. So mainly avoid pertussis component. So I'm not sure of the options, just we made options as much as possible. So we have to avoid pertussis component. That's all the message. So there was a population of 10,000 people in a village or in a place or in a study site. They were followed for 5 years. So now we are having 10,000 people. What they are doing, they are following them for 5 years. So if we follow what type of study, it is a cohort study. So if they are given in the question till this, it is a cohort study. But there is something extra. So 2,000 people developed the disease. So out of the 10,000, so 2,000 people developed. So till here, it is a cohort study. Okay. Then 2,000 controls are chosen from the rest for comparing them with the cases. So 2,000 developed the disease. Now what they are doing, from the remaining 8,000 people who are not diseased, they are choosing the controls. So what they are trying to do, they are trying to do a case control study inside a cohort study. So till here it was a normal cohort study. But now from the cohort study, from the non-disease people, they are taking some controls. So what they are trying to do, they are trying to do a case control study inside a cohort study. So when they try to do a case control study inside a cohort study, it is called as a nested case control study, nesting. So nesting a case control study inside a cohort study, it is called as a nested case control study. If you see the nested case control study, there will be an unknown exposure and a new rare disease. So they would want to find what is the unknown exposure causing this new rare disease. So nested case control study, it would be done usually for a new rare disease with an unknown exposure. The diagram of nested case control study taken from this article. So normally we have a cohort study. In this cohort study, we are taking all the cases. Then for these cases, we are taking a sub-cohort, we are taking some controls, and we are comparing. This is called as a nested case control studies. Okay, so this is a diagram of a case cohort. This is a diagram of a case cohort. I actually wanted to show you the diagram of a nested case control study. So nested case control study. So what we are doing? So we are taking a population. From the population, we are taking the diseased. For the diseased, we are taking the controls from the same population. This is the diagram for a nested case control study. So keynote trial is related to. So what is the keynote trial related to? It is actually mainly a pharmacology question. There are many trials. So there are numbers are given to various trials. So this keynote trial 042, I hope it was asked in the exam. It is mainly for the study of pembrolizumab. Mainly for this cancer therapy, there are many trials going on. You can see these trials registered on clinicaltrials.gov. Many clinical trials are going on. You can see them on clinicaltrials.gov. So it's also a very hard question. You cannot see all the trials. Possible 1 or 2 trials recently listed, you can check out that. So keynote trial. So based on the number, it can vary. So 042 pembrolizumab. Next question. The following diseases categorized as a category B bioterrorism agents. So bioterrorism agents, we are generally categorizing them as A, B, and C. C stands for new emerging infections such as Nipah virus and hantavirus. They are all around the new emerging infections, Nipah virus and hantavirus. Then category A, they mainly stand for very severe diseases, can cause lethal effects, smallpox, tularemia. Then below the range, somewhat it is less severe compared to category A, it is brucellosis. So brucellosis comes under category B. Brucellosis comes under category B. Smallpox and tularemia, anthrax, they all come under category A, bioterrorism agents. Then Nipah virus, hantavirus, and all they can come under category C, new emerging infections maybe. So brucellosis will come under category B. So we can see the list on CDC. CDC gives a valuable list of all the bioterrorism agents. All the following are true about incubation period of the disease except. So COVID-19, yes, shortest can be 2 days, longest can be 14 days. It is right. Chickenpox, yes, around 1 to 2 weeks or even 3 weeks. It is also okay. For hepatitis A, it is around 15 to 50 days. So it is around 15 to 50 days hepatitis A. It is right. But syphilis, it is more than that. It is not 1 to 2 weeks. Syphilis, it will take a lot of time. It will take around 90 days. It can even take up to 90 days. The median incubation period, on an average, it will take around 21 days for syphilis. Syphilis, on an average, it will be taking around 21 days. The average incubation period was 21 days. Incubation period can last from 10 to 9 days for syphilis. So syphilis alone, they are given wrongly. All others are right. Next, the following formula is used to denote. So what was the formula given was root of sigma x minus x power the whole square divided by n. So this is the formula. It denotes standard deviation. So what is the formula for standard deviation? It is nothing but square root of summation. Summation of mean minus all variables divided by n. If n is more than or equal to 30. So this stands for mean. This stands for each variable. So suppose in the question they are giving 5 variables. The weight of 5 variables are 3 kg, 4 kg, 5 kg, 6 kg, and 7 kg. So you have to find the mean. So 1, 2, 3, 4, 5. So 5, 7, 12, 18, 25. Multiplied by 5 is 5. So we will find the mean. So the mean is 5. Then for each variable, you will find the x minus x bar. So 5 minus 3 plus 5 minus 4. So for everything, you have to do square. So plus 3 square plus 5 minus 4 square. So adding everything, you will get a number. Then this number you have to divide by n and take square root if n is more than or equal to 30. In case if n is less than 30, then n minus 1. In case n is less than 30, we have to do this n minus 1. This is the formula for standard deviation. Next, what is the formula for variance? So variance is nothing but square of standard deviation. Variance is nothing but square of standard deviation. Then it will be sigma x minus x square the whole square divided by n. N is more than or equal to 30. So x minus x square the whole square divided by n minus 1. Minus 20. So because this is the formula, so standard deviation is nothing but square of variance. That's all. That's simple. Next, one of the following is strongly matched. I cannot get all the details, but you can remember cold, anthracosis, Buckland syndrome, asbestos mainly affects the lungs, surrounded by pleural layer. This pleural layer is affected. So we mainly get something called mesothelioma. Then Sugarcan. So we can get a disease called bagasosis. So silicon, crystalline silica dust. So I could not get all the options which was right. So I'm just telling these are the two things. These are all true. After matching, I'm giving you. After matching, I'm giving you. sugarcane bagazosis, then cotton dust, vaginosis. These are some of the occupational diseases. Cotton dust, vaginosis. So sugarcane bagazosis, as you can see, is now you know the sugarcane. We are putting it in the machine and we are getting something called chakka. So this is used for making cardboards. So what is the disease common in cardboards? We can get bagazosis. Mean plus or minus 1 standard deviation corresponds. So it is an easy question. So, it's normal distribution curve. So mean plus or minus 1 standard deviation corresponds to 68.3% of the curve. Then we have mean plus or minus 2 standard deviation and plus or minus 3 standard deviation 99 plus so mean plus or minus 1.96 standard deviation, it corresponds to exact 95%. Corresponds to exact 95%. Maximum thermogenic effect is seen in. See what is thermogenic effect. You see what is thermogenic effect? It is nothing but the energy required to digest each macronutrient. That is called as the thermogenic effect. It is measured as a percentage of energy provided by it. So for protein, we need 25 to 30% of the energy provided by it. So the maximum thermogenic effect is seen in protein. So in order to digest the protein, we need at least 25 to 30% of the energy provided by the protein. In order to digest the carbohydrate, we need 5 to 15% of the energy provided by the carbohydrate. For fats, around 0 to 5%. So the maximum thermogenic effect is seen in protein, 25 to 30%. So the energy required to digest each macronutrient is measured as a percentage of the energy provided by it. So that's all, students. Thank you. So don't worry about the exam. All is well. Okay. So don't worry. Always be smile. Yes, smile. Everything will be good. Okay. You have done the exams. So you will get good results. See you again. Bye.